Let us solve question number 11, guys. So what do I have here? A question from atomic structure. It is based on hydrogen spectrum. Your favorite, guys, a very easy question. The shortest wavelength of hydrogen atom in the Lyman series is lambda 1. The longest wavelength in the Balmer series of He plus ion is. If I'm talking about the shortest wavelength is maximum energy. So you are going from infinity. The electron is jumping from infinity to what? To the first orbit, because you are talking about the Lyman series. Okay. So 1 upon lambda 1 will be equal to what? R 1 upon 1 square minus 1 upon infinity square, and that will be hydrogen. So you are talking about 1 square, right? So this will be what? You will get R as what? If I solve this, you will get R as 1 upon lambda 1. We'll get R as 1 upon lambda 1. What is the second part of the question? The longest wavelength in the Balmer series of He plus is. So we have to solve for He plus. So how we'll go about it? So 1 upon lambda 2 is equal to R 1 upon 2 square. Why did I take 2 square? Because it is mentioning the Balmer series. It is talking about what? The Balmer series, right? So 1 upon 2 square, and then the longest wavelength. If I'm talking about the longest wavelength, it is the shortest in energy, right? So the energy is shortest. So minus 1 upon 3 square, right? So the electron is jumping from the third orbit to the second orbit. So the energy will be what? Energy will be least, wavelength will be maximum. And since you're talking about helium, so you'll multiply it by what? Z square. So that will be 2 square, because Z for helium is 2, right? So what we'll have here is, we will get 1 upon lambda 2 is equal to what? 1 upon lambda 2 is R, we got as 1 upon lambda 1. So this, if we solve, we will get it as what? We will get it as 5 by 36 into 4. So the value of lambda 2 would be what? The value of lambda 2 would be 9 lambda 1 by 5. Okay. Is this clear, guys? So this is our answer. So let us match it with the options which are available to us. Okay. Yes, it matches with option 4, guys. I hope you have understood this. Yes, a very simple question, just that a little bit calculations are involved, nothing else. A very easy question, guys. Let's move on to the next question. Question from organic chemistry. Okay, we have ethers, we have alcohol. Okay. The major product B in the following reaction is. So what you have is, you have a ether given. To ether you are adding Hi. So what will take place? The ether bond will break. Ether bond will break. Okay. So as you are adding Hi to this, you will get an alcohol. Okay. So alcohol will react with H2SO4 and it will give you what? It will undergo dehydration. As it undergoes dehydration, it will give you an alkene. It will give you an alkene. So let us look at the steps. Okay. First we are adding Hi to this. So as we add Hi to this, what will happen? The bond will break from here, because iodine will get attached to the alkyl group, which is what? Which is less hindered, right? So iodine will get attached over here, and here we will get a H, right? So the alcohol over here is the bigger alkyl group, with the OH is your alcohol. Now to this, if I am adding H2SO4, then what happens? Let us see that, guys. So the alcohol over here is CH3, CH2, you're carrying out dehydration of this, right? So as I carry out dehydration of this, what will I get? I will get CH2 plus, which is unstable. So there will be a 1,2 hydride shift. There will be what? there will be a 1 to hydride shift. So as you are shifting this hydrogen, as you shift this hydrogen, what will I get? We get a carbocation over here. So this will carry a positive charge. Now it will follow Sedgwick's rule of elimination. As it follows Sedgwick's rule of elimination, so what will be the product? We'll get CH3, CH, double bond C, CH3 and CH3. So this is our product, guys. Let us match it with the options which are available to us. Okay. So what is the answer, guys? So the answer is option 3. Okay. Is this clear how we got the product, guys? Is this clear to all? Yes or no? Yes. Let us proceed ahead, guys. Okay. Let us move on to the next question. So it's from thermodynamics. So 5 moles of ideal gas at 1 bar and 298 Kelvin is expanded in vacuum. Okay, so let us note this down. So it is in vacuum. Okay, to double the volume, the work done is. Do I really need to calculate this, guys? It is such a simple question. If I am talking about expansion in vacuum, what will be the work done? The work done would be, any guesses? It is free expansion, guys. Free expansion work done is 0. Okay, a very, very simple question. I'll say it's a bonus question, guys. Okay, let us move on, guys. Let us solve question number 14.